The biggest challenge to isolating the DNA from the bone is that, first of all, the DNA is degraded because it's been out in the environment for so long. There are biological contaminants as well as environmental deterioration. And the bone is made up of 70% minerals. And through traditional DNA extraction procedures, those minerals will inhibit the DNA molecules from being isolated. So Ken Crowder, he gave me a paper describing a new technique of demineralization to kind of break down those minerals so that we can extract as much DNA as possible. Because there's so little in here, and the system by which we were analyzing the DNA, it needs a lot, this technology. We need quite a bit of DNA, and it has to be pure and clean. So the first step was to sand off the surface of the DNA, of the pieces of bone, in order to remove any contaminating DNA from people that had handled the bone, as well as any kind of surface dirt. So that's what I did. I took a little piece like this and I sanded the surface. And at that point, then I put it in different cleaning solutions in a sonicator. Then I pulverized the bone into a powder using a grinder, a cryogenic grinder. And then I took the powder and I put it in the solution which dissolves minerals. And that way, all the DNA that was in there was able to be extracted through traditional methods at that point. To be hybridized to the chip is actually injected through these septas into the back of the chip. And it fills up this window. So after the chip is hybridized, what happens is the chip is placed in the fluidic station here, and different solutions are put into these tubes. One is a stain, one is an antibody solution, and one is a wash buffer. And there are specific protocols for different types of chips that you use. This one is human. Once it goes through there, you take it out of here and you put it into this machine here, and it scans the chip with a laser, and it takes about a half an hour, and at that point you get a raw data file which then generates a cell intensity file, and each one of the tiny little squares in the cell intensity file represents a SNP, a single nucleotide polymorphism, which identifies the genotype call for that particular SNP. This is before I did the microarray processing. This is just after I isolated the DNA. I ran it out in a gel and I took a picture, and I was guardedly optimistic because I definitely got DNA, which was thrilling, but at this point you don't know if it's human or microbial DNA or, prairie dog DNA. You don't know what it is, but there definitely is DNA there, and it's very clean. So that was pretty exciting.